Hello and welcome to Mr. Thompson's Math Tutorials. Today we're going to be looking at addition of radicals. Okay, sort of just like fractions, um, I can add like radicals just like I can add like fractions. So this is not that different than saying 4 and 1/3 plus 1/3. I have 4 1/3 and I have 1/3. 4 and 1/3 and I have 1/3. And this is actually the same as 4 and 2/3, right? So I can add these together because they have the same denominator. I can add these together because they have the same radicals. Okay, so let's have a look at that. Essentially, I have 4 radical 3 and 1 radical 3. You can't see it, but there's a 1 here. It's assumed. I always call them ghosts, but there's a ghost 1 there. So I have 4 of something and 1 of something. That's going to give me 5 of those somethings. So this would be 5 radical 3. Okay? All right, here we go. I've got negative 3 and then the square root of 5 plus 3 and the square root of 3. So these are not the same, so I can't add them together. So it's very similar to if you had 4 and 1/5 plus 1/3. You couldn't add these together. Okay, you could make them similar and then add or find the lowest common denominator and add them together, but we're not going to do that here. The only thing I could really do in this case would be to factor out a 3. I've got a 3 and a negative 3 in front of this and a 3 in front of this. That means those two could be factored out of this, and it could end up being 3 times the negative square root of 5 plus the positive square root of 3. Okay, but that's pretty much the only thing I can do there. Let's look at another example of this. When I look at this, I've got negative 2 and the square root of 27 plus 3 and the square root of 12. Now, they're not the same. These are not the same. My square roots are not the same. Therefore, I have to see if I can simplify and see if I can try to make them the same. So let's simplify both radicals. Okay, so here we go. This would be 9 times 3. Again, I'm looking for um, a perfect square. So a number times another number that gives me 27, and one of those numbers being a perfect square. Okay, let's do the same thing here. This would be 3 times. I'm looking for perfect squares, so I know 4 is a perfect square times 3, and that gives me 12. And once again, I'm not going to use 6 times 2 because 6 and 2 are not perfect squares, so those won't work for me. Or 12 times 1, those are not going to work for me. So I want to look for the factors that have a perfect square in them. All right, so let's continue on. This would be 2 times the square root of 9 times the square root of 3. Sorry, that would be a negative 2. And this would be 3 times the square root of 4 times the square root of 3. Now, this is a perfect square. The square root of 9 is going to give me 3. So that would be negative 2 times 3 times the square root of 3. And this is going to be 3 times the square root of 4 is 2 times the square root of 3. Now I can collapse this, and let's see, I've got negative 2 times 3. That's going to give me negative 6 square root of 3 plus 3 times 2 is 6 and the square root of 3. So interestingly, negative 6 and the square root of 3 and positive 6 and the square root of 3, if I add those together, I get 0. Let's look at another example. So here I've got 3 different square roots. They're not the same, so I'm going to try to simplify them and see if I can make them the same. So let's see. A perfect square in 48 would be 16 times 3. Okay, I've got 5 times. I'm looking for perfect squares in there again, and the perfect square in there is 25. So 5 times 5, or 25 times 5, sorry. And then 2 times, and let's see, the perfect square as we saw from the other example, and that would be 9. Okay, so I can simplify this. This would be 3 times the square root of 16 times the square root of 3 plus 5 times the square root of 25 times the square root of 5 plus 2 times the square root of 9 times the square root of 3. The square root of 16 is 4, so this would be 3 times 4 times the square root of 3 plus 5 times the square root of 25 is 5 times the square root of 5 plus 2 times the square root of 9 is 3 times the square root of 3. All right, so this would be 12 and the square root of 3 plus 25 times the square root of 5 plus 6 times the square root of 3. Now I have two square roots that are the same now, and those can be added together. So I'm just going to rewrite this problem so that they're gathered, so that I've gathered the like terms. So 12 times the square root of 3 plus 6 times the square root of 3 plus 25 times the square root of 5. Okay, and then I can add these together. So that's going to give me 8 square root 3 plus 25 and the square root of 5. All right, thank you for watching.